Hi everyone, so this is the continuation of continuity of a limit, and for this video we're going to have the function. Graph is not given, so we're going to identify or determine if the function or the limit of the function is continuous or not continuous. So to be able to do that, we have three conditions or criteria or tests to satisfy whether to determine the limit of the function is continuous or not. So the first step or the first condition is that the f of c exists. Okay, meaning it is not undefined or indeterminate. Okay, so not undefined nor indeterminate. And we normally see this if we have a rational function, so we check if the denominator is not 0. So when it's 0, if the denominator becomes 0, then it's undefined, indeterminate. So the function does not exist. Okay, second step or second condition is that the limit of f of x as x approaches c exists as well. Okay, what does it mean? It means that it's not D and E. Okay, it's not, does not exist. And to check this, we need to verify our left hand side limit and left hand side limit. Okay, so the limit of f of x as x approaches c to the left hand side is equal or exists, okay, or equal of limit of f of x as x approaches c from the right. So if they're equal, the left hand and right hand side limits, then it means our limit exists. Okay, and the last step or last condition is that our limit of f of x as x approaches c is equal to f of c. So in other words, step 1 or step 2 or condition 1, condition 2 must be equal. So if we satisfy these three, then the function is continuous. Okay, let's have an example. So let's find this f of x equals x squared minus x minus 2 over x minus 2 is continuous at x equal to 0. So the first step is to determine if f of c exists. Okay, so it means f of 0 exists. So f of 0 equals x squared minus x minus 2 over x minus 2. So by substitution, it's negative 2 over negative 2 is equal to 1. Okay, second step, the limit of f of x as x approaches 0 exists. So since this is a rational or polynomial expression, so we can use factoring. Let's factor the numerator. Okay, so this is a trinomial. So this would be x minus 2, x plus 1 over x minus 2. So we can cancel this. So we'll have the limit as x approaches 0 will be x plus 1. Okay, so by substitution, this is equal to 1. And the third step, we could see that step 1 or condition 1 and condition 2 are equal. Okay, condition 1 is equal to condition 2. So therefore, the function or the f of x is continuous at x equals 0. Okay, next example, we'll use the same function, but this time the question would be, is it continuous or not at x equals 2? So by substitution, we can already see that our denominator would become 0, so therefore this will be undefined. Okay, but let's proceed with our test. So the first step is f of c exists. Okay, so if we substitute 2, so 2 squared minus 2 minus 2 is equal to 2 minus 2. So this is undefined. Okay, because we have a denominator 0. So therefore, the function f is this continuous at x equals 2. Okay, let's have one more example. F of x is equal to, so we have piecewise function, 2x plus 5 if x is greater than or equal to 3, x squared minus 2 if x is less than 3 but greater than or equal to 2, and the square root of x plus 2 if x is less than 2. So let's start with the first step. Identify if f of 2 is or does exist. So since we need f of 2, we're going to use the function x squared minus 2. Okay, so x squared minus 2. So substitution, 2 squared minus 2 is equal to 2. Second step is to identify the limit of f of 2 exists. So since we have piecewise function, let's test the left hand side and right hand side limit. So the limit of f of x as x approaches 2 from the left. So in that case, from the left, we're going to use x less than 2 functions. So that's the square root of x plus 2. So 2 plus 2 is 4, square root of 4 is 2. And then the limit of f of x as x approaches 2 from the right side. So we're going to use the second function, so x squared minus 2. So 2 times 2 or 2 squared is 4 minus 2 is 2. So as we can see, the left hand side, right hand side are equal. So therefore, step 2 or condition 2 exists, or the limit exists. So therefore we can say, or yeah, for condition 3 is that our condition 1 is equal to the condition 2. They're all 2. So therefore, the function is continuous at x is equal to 2. Let's have this function f of x is equal to the square root of x minus 1 all over the square root of x plus 1, is continuous at x equal to 1. So by inspection, if we substitute our x equals to 1 in our denominator, we'll have 1 plus 1 is equal to 2. Okay, so let's do that. So step 1. So f of 1 is equal to 1 minus 1 over 1 plus 1. So we have 0 over 2 or 0. Step 2. The limit exists. So the limit of f of x as x approaches 1 exists. So let's do this by substitution as well. So 1, square root of 1 is 1 minus 1 over 1 plus 1 is equal to 0 over 2 is also 0. So for step 3, condition 1 is equal to condition 2. Therefore, the function f is continuous at x is equal to 1. Let's go with our last example with piecewise functions. So f of x is equal to 2x plus 5 if x is less than negative 1, x squared plus 2 if x is greater than negative 1, and 5 if x is equal to negative 1. Is it continuous at x is equal to negative 1? So let's start with our first condition or first step. So f of negative 1, so we'll choose this function, and that is equal to 5. Second step, let's check if the limit exists by checking the left hand side and right hand side limit. So let's start with from the left, negative 1 as it approaches from the left, so we'll use less than 1, so that's 2x plus 5. So this would be equal to 2 times negative 1 plus 5, so that's equal to 3. And then the limit from the right hand side, so as x approaches negative 1 from the right, so we'll have greater than negative 1, it's the second function, so x squared plus 2. So negative 1 squared is 1 plus 2 is 3. So as you can see, the limit exists, right? But for condition 3, our condition 1 is not equal to condition 2. So it means the limit of f of x as x approaches negative 1 is not equal to f of negative 1. So therefore, the function is not continuous. Okay? It exists, but it is not continuous. The function is discontinuous. What does it mean with the graph? It means that there is a hole, probably something like that. Okay? So it exists, but it's just not continuous at x equal to negative 1. Okay? Thank you.